Sir,
Hello. Yes.
just one more curiosity. Can you just explain this dashboard little bit more? You know, how to see the dashboard, how to understand it.
Dashboard. Okay. So now, as you can see, basically, on the dashboard, basically, first of all is what it shows all the components of your SD-WAN fabric, right? Like that.
Yes.
Then we have already seen that you have, this is, as I just now explained, your control status. This basically, this particular section is related to the control connections. Basically, every vantage needs to have connections to all the controllers. Okay, like that. So if some vantage goes down, it will show here basically control down, or maybe if one of the controller is connection is down, then it will show partial basically. Then the next section down, vantage inventory. Again, this also we had seen basically. So we this is where we uploaded that serial file, and according to that serial file, we got basically 12 devices which we are authorized to basically integrate in the SD-WAN fabric. Out of that, right now we have deployed 5. Then if the users are basically, see, this is basically like like application monitoring, as I said.
Okay.
Another benefit of SD-WAN or software defined networking is what, since it's a software, so basically monitoring will be basically more graphical, like that. So you can, it can show basically like on normal traditional routers and all, how we have basically this in basically net flow, we have basically this top talkers policy. If you want to see which application is being used maximum users can, so like that same way over here you have basically top applications, if the applications are running. Then this SD-WAN also has basically support for firewall. See, if you have a firewall implementation, then you can even have firewall basically, maybe whatever the sessions, it will start displaying that, okay, this many sessions check, because it will be a stateful behavior of the firewall. Then see, optionally it can do even URL filtering. If it has basically like intrusion IPS features also basically, which can be integrated. So top signature hits, URL filtering if configured. So from security point of view, if those things are configured, that can be also possible. Then again, you have basically, you see here basically right now it is showing application AA. This is called as what? AAR, application aware routing basically. Like basically it's like basically kind of QoS basically. In quality of service, basically basically you want that, okay, maybe a particular application from a particular basically vantage basically, we can see basically, see how much is that for that application, what is the latency, what is the jitter, what is loss, basically how much percentage. It can show you that my packet, if some packet losses are there, it will show you that, okay, this many packets were lost basically. So this is related to that. All it is showing all the vantages over here, like that. And then this is basically related to, again, site. This is what we saw basically, it is I have configured how many site IDs, guys? If you remember, I configured site ID 22, then basically 144, 111, 113, right? And then basically one more site ID. So altogether, based on that site ID, it is showing that, okay, you have basically 5 sites which are currently basically connected. And then again, basically how many, this is again related to bandwidth management basically.
Sir, could you maximize this one a little bit if possible?
It is full screen only for me.
Okay. Okay.
Let me just clean up. Oh, what has happened? Oh, yeah.
Sir, this control status, not the first one. There are total 6. What is that 6, sir?
1 second again. For every vantage, every vantage, it has to establish 2 connections basically, 2 control connections to each controller. We have 3 controllers, correct?
Yes.
So per controller, two connections are there, inbound and outbound. Like how we have basically in IPsec, we have basically inbound SA and outbound SA.
Yes. Yes.
Same way here, two-way connection, two-way control is there. Basically.
Oh, okay. Two one-way
connections are there. So it altogether shows 6 control connections basically.
Okay. Okay.
Per controller, 2 connections will be there, inbound, outbound.
Okay.
Because in this environment, basically we have basically what push-pull environment. You know, it's not only like controllers sending some information. Even the manages also, they will send some information to the controller. Like in how SNMP is a push-pull model, correct? Like that. SNMP manager can also proactively ask for information from the SNMP agents or the clients. Similarly, clients, whenever something will happen, they will send the SNMP traps to the SNMP manager, right? So same thing, push-pull environment. So here also it is a push-pull environment. So controllers, WAN edges making connection to the controller, and controllers also having a connection to the WAN edges. So that's the reason for controller, 2 control connections will be there. That's the reason I said, that vSmart, I said, according to the documentation, what is the recommendation that if maximum vSmarts can handle 2000 control connections. So control connection means not per one manage means one control connection. So one device will have basically minimum 2 control connections. So 2000 connection basically means what? Only 1000 devices. So if you have more than 1000 devices, then the customer has to go for another vSmart controller. Even if they have less than 1000 also, still Cisco will insist for the customer to go for a production environment. They will insist to have minimum 3 vSmart controllers. Okay, guys. Shall we proceed now?
Sure.
Okay. So yesterday what we had done, we made all the WAN edges were integrated, and then second requirement is what? Behind the WAN edge, whatever is the LAN side. In case of Los Angeles, basically it was purely a LAN, but on the other devices, Dubai basically and basically New York, we kept what? 2 segments basically, and then basically according to our requirement, we configured all these things. So VPN 100, if you see, VPN 100 is basically on all the locations, whereas VPN 200 is only on certain locations. So like in a real world environment, there could be different kinds of requirement like that. So that yesterday we achieved, correct, guys? So this we achieved yesterday. Let us see today again, as I said, graphically. Let us see how we can check that. Again, where you go, monitor menu. We go into network. We see all the WAN edges basically. Let's take again basically LA. Let me take LA. I go to where? Troubleshooting section. In troubleshooting section, you see we have ping options to do ping. We have options to do basically trace route. Control connection. See, if you want to see control connections here from this WAN edge. See, it shows 2 control connections, one to vSmart and one to vManage. Right now it is showing. Okay.
vWant is grayed out in that list. vWant's grayed out actually.
Is it?
That list it shows device. No, in that
okay,
list which you saw, right? Yes, if you see that.
No, it's
no, the symbol left
color is
side.
like that.
Its color is like that.
Okay.
Its color is like that, purple pinkish like that color is there. vBond normally see vBond is only in authentication time basically. So where I was, LA. So I go to troubleshooting section. See here also it can show you what is the utilization, CPU utilization, memory utilization. It will show basically, and then basically related to of course these are not available now basically, but power supply, fans. If it is a real hardware, then basically all this thing also it will show basically. If you have real hardware boxes basically, then all this thing it will show. We can even reboot the device. If the device crash, then it can have a crash history basically, it can show basically. And you can see basically you can have basically 1 hour, 2, 3 hours monitoring, 12 hours, even 7 days, or we can even customize also basically. And it can show you in a particular time what is the CPU utilization, like every unit it is showing, like maybe 5 minutes like that, it will show you basically. Okay, coming back to this now, troubleshooting. I go inside troubleshooting menu, simulate flows right now. So when I say simulate flows, like right now we can see now on LA, that location, how many VPNs are there? Only one VPN is the service VPN. So basically, we can see only VPN 0 and VPN 100 only I can see. Then it will show me what is the interface. If I still drop down, it is showing me the correct interface. Gigabit 0/2 is part of that. So automatically it picked up that IP address from that interface. Then it is asking me, okay, where you want to simulate. So let me simulate from LA to, I don't know what is the IP. Let's go. Router 33. Let us take router 33. IP interface brief. Let us 172.16.33.33. Okay, let us select this. Let's see. Copy. Come here. Paste. So it is showing me. It is simulating a flow, how the flow will go like that. And now if you see, it is showing the LA. What IP it is displaying here? Which IP it is displaying? It's the system IP, not the outgoing IP. And destination also, if you see 10.133.1.151, this IP is what? Again, system IP. So every vantage now, they know each other by what? Their system IP. They call each other, like how in OSPF the routers know each other by their router IDs. Like that, same way over here also, they know each other by their system IP. See, it is telling only remote system IP, like that. Okay. And what encapsulation it is telling? I will use IPsec encapsulation to send the packet to this guy destination. So if I say that, okay, this is the destination, I specified the destination, the IP address on router 33. So it is telling my LA router, LA vantage is telling if I have to go to that destination, I have to send the traffic to this guy. And how I'll send this traffic? Use encapsulation IPsec I'll use. And what is the WAN service I'm going to use right now? It is showing, you see, business internet. And it is showing return also, that return also traffic will come on the business internet only, like that. So it is showing how the traffic will go to the destination, and from the destination how the traffic will come, which WAN service is going to means. And this name what we defined is called as what? Color, right? This is called as what? Color. Color means what? The WAN service. Like that. So see, a very nice feature, simulation. We can actually see how the traffic is going to flow from one vantage to the other vantage basically. But the thing is now what? Suppose now, see what I'm going to do now. We are going to simulate a failure. So I'm sending this traffic. Let me fail basically. Okay, let us fail this interface on iNet router. The interface towards Dubai. What happened? 1/0. And just now.
Abhi sir, are you talking? I am not able to hear your voice.
Yes, sir. Hello, sir.
Hold on. So if I go now, you see now, one is down, it is telling one manage is down, so control is down now. Okay, like that. And basically, if we go to again the monitor menu, network menu, again I select LA. Again, I go to troubleshooting section, simulate flows, select whichever VPN you want to simulate the traffic. Destination again, I select New York. Oh, I down Dubai, right? Sorry. I think what is in 192.168.44.44 Dubai, because I down the Dubai link basically. And you see now it is telling black hole. See, it is telling that no, now you cannot go reach the destination. So when the destination is up, it will show you the destination is up. Now Dubai is no longer available. Again, we make this link up. Just we need to give time, we need to wait. Again, it will, the manages come, but it has to establish the connection. So it will show up a little later because it has to converge. Again, if I go now, network, select the device, go to troubleshooting, simulate flows, select the service VPN, select the correct interface and destination again one time. This thing. Now it is again showing that okay, this is the remote system IP 10.1.144.151 like that. Now in this system IP also actually, while configuring we have done some, some mistakes. Some places if you see the second octet I am putting the site ID, whereas here if you see the third octet I put the site ID. Anyway, it's not a big thing, but I'm just saying because normally we should have done like that. Okay. Either third octet should be the site ID or maybe the second ID, like somewhere randomly second octet I'm using the site ID, some places third octet. So this is inconsistent. Anyway, that is
so sir, now if we use let's say DNS server, okay, then maybe the system IPs we can give some name also, right? Possible?
No.
No, huh? No. Like in router in OSPF we do it, right? We cannot do it here.
No.
Okay.
Now, so what is the problem now? Right now, what this organization is facing the problem? The problem is what? WAN. Right now this topology has what? Only one WAN service. So it is basically single point of failure right now. The WAN is basically, if WAN fails in some location, then that particular location will get isolated like that. Correct? If the internet router, if I shut down the internet router, what will happen basically? Then all the locations will get isolated. So that is where now this organization decides that, okay, no, we will go for what? A second alternate WAN service, and they say let us have MPLS, not another. It could be another internet connection also from another service provider also today. So both both the WAN service can be same type also. But in our lab environment, we are just thinking that let's assume that this is basically MPLS environment. Okay, so second service provider basically is like MPLS environment. And this second service provider now, how is going to extend the routes? For the second service provider, the second WAN service MPLS. In MPLS, basically, to exchange very large number of routes, basically service providers, they use basically what BGP. So through BGP, we are going to do this second WAN service.
Sir, sorry to interrupt.
Yes.
Yeah. Right now, we have shut down the interface that is connecting to Dubai, right?
Dubai, yes.
So, how the monitor will happen if the VPN interface alone is shut down? Like we have two VPN, right? One is VPN 100 and one VPN 200 in Dubai.
Yes.
So if VPN 200 alone is that interface we made down.
No. See, I did not make the VPN.
No, I'm not asking. I'm not asking that. What my doubt is, if we shut down VPN 200 interface, what would be the information we can see in the GUI? Like what kind of notification?
No. See, in the dashboard, you can only see the control connections. So if there is a failure in the transports VPN side, VPN 0. That will reflect in the dashboard. But suppose, as you're saying, suppose there is a failure here. Let's say this interface has gone down, right? This is basically, let's say this is VPN 100.
Okay.
So in VPN 100, this interface has gone down. What is happening? This is like one of the link failing. If this is OSP, what will happen? Immediately this guy is going to send what? OSP. It is going to send an OMP update.
Yeah.
It will say, okay, this segment is down now. That's it.
Okay. So,
and then vSmart will inform everybody, hey, this segment, let's say this segment was network X. So X went down. Immediately Dubai WAN will send and pass on that information. Network X in VPN 100 not available.
yeah,
vSmart will update itself and then it will forward to everybody.
But being a monitoring, if we use this GUI, we will not able to come to know, right?
No. That is, see, monitoring, these controllers basically, they have, if you see the dashboard, if you see this thing, controllers can have reachability up to where?
In the fabric.
In the fabric. So they have basically reachability like this.
Yeah.
So if this in this side any failure is there, then that will reflect, okay, this connection has gone down, this WAN service has gone down. But a failure behind the WAN edge, the WAN edge itself has to be, then that is a routing failure, no? Basically a particular link has gone down, so that router has to announce, okay, I no longer have this link, like that. That is how OSP will work. No? Link state, whenever a link will go down, it will immediately generate an LSA.
I understand that one. Like what I'm asking is like, so we cannot identify through this window GUI if the customer end, if anything down. Only the routing table or something, whatever will get update. Finally.
Yeah, in the routing table only we can come to. I can check basically in vSmart. I can check in vSmart. I can check the routing table for a particular vSmart for a particular VPN. I can say, okay, show me the routes for particular VPN 100. So it will show me. So
we have to go inside and check if any
No.
information we get, then only we'll be able to
No,
check. Otherwise,
that is, see, no, that is possible. See, as I said, in a real live environment, big environment, what people will do anytime the links are going down, you want that information to get reflected, correct? Basically, you want that thing to be updated. It should not be basically like a, reactive approach. It must be proactive, like that. So in that case, basically, there are special tools basically available. You require additional software integration with SDWAN to
okay,
do that,
got it.
to do that monitoring.
Got it.
Like I will show you here, we have one option here. Let me show you in hold on. Where is it? No, where it went? See this V analytics. So you'd require some additional software integration and licensing. This capability is there. Okay, hold on. That capability is there, It is optional. It doesn't come by default. This V analytics, basically it will require basically additional software integration. If I click, because we don't have that license here.
Okay.
So using that, and then there are other other third party tools also available. So you have to integrate, like how in a production environment for monitoring, basically people will use additional software like HP OpenView, IBM Tivoli, or WhatsApp Gold, or basically like that. So many softwares are available like that.
Okay.
So same way here also there are possibilities. Not like that it can't be by default. No.
Okay. Thank you.
Okay.
Or that if that has one image, we can see, right, sir? That is
yes. So if anything will basically you will immediately get basically pop-ups basically. Okay, this link has gone down. When it will be basically configuration will be required, like how same in SNMP basically. When we configure SNMP, when we enable that, okay, SNMP, you have to trigger traps for this particular application. Whenever in like in SNMP, I can do SNMP enable traps OSPF for LSA basically, or state change like that. When I configure that, then the router, anytime there is some LSA generation, it will immediately send a message to the SNMP manager like that. So that is possible. But by default here in this dashboard, the dashboard what we see here right now, in this dashboard it cannot show WAN failures happening behind the WAN edges, because that is basically routing basically control plane information. But immediately it will get reflected to everybody. Everybody will come to know that, okay, VPN 100, this particular segment is no longer available. Okay.
Yes, sir. Thank you.
Okay, so now we go further now. So we have understood that the problem is what right now this organization, they have single WAN service, and that means only single dependency is there. So if that service is not available, business will stop working. People will not be able to access their business applications. Users will not be able to do their work. And that's the reason management now decides that no, they can't have like this downtime. If the internet goes down for maybe 1 hour, if 1 hour users are not able to access their applications, it will be a big basically issue. So now the management decide that they will go for a second WAN service, and that WAN service they have decided to, maybe they will take it from some other service provider. The service also they decided let us have a maybe MPLS connection basically. So now first thing is what we'll need to get this MPLS service provider up. So let us go to the MPLS router. It's blank. And as I said, now in MPLS environment, basically the routing protocol, say in case of internet, what was the routing we did? On all the WAN edges, what was the routing we did? Yes, guys, in case of internet,
route.
it was only a
Default.
default route. Okay,
Default.
all the managers we just configured default route. But now in case of this thing, what I have decided is what we'll be using BGP to extend the routes. Okay, like that, because maybe we have basically 10,000 locations. So we don't want to use basically, you know, like it could be IGP also. I could have used IGP, but since IGP we are already doing in the service VPN side. So I decided let us have BGP on the service, you know, in the VPN 0 side also. So in the transport VPNs also now we'll be having BGP, and that's the reason let us first configure our MPLS router. So I already created the script. Again, an issue is there. All the interfaces it is showing gigabit. Oh, good. Replace. Control A, Control C. And now you see here, you know, what is the IP addressing I'm using. So in MPLS cloud, basically the service provider is using what? Subnets of 10. Okay, like that. So I have configured. And now one problem is there. In this organization, this service provider BGPS number is what? 100. But he's thinking this XYZ organization, his AS number is what? 200. So I need to 100. Because yesterday, if you remember, I decided that the AS number will be what? 200. So I need to correct this one first. Looks good. For testing purpose, I'm advertising one network also. Okay, /20 for some look back like that. So I know, like as I said, if somebody wants to practice OSPF, so I kept OSPF also. But right now we are doing BGP only. So Control A, Control C. This router. So IP interface brief. So E0/0 got this IP, 0/1 got this IP. This will be LA. This is data center. This is data center. This is LA. This is New York. Why Dubai did not come up? Administratively down. E1/0. Okay, something went wrong here.
Some of the command line did not take. There was some error.
So see, the problem is here basically, because here if you see, it is showing 2 slots, you know. In this basically on the router, basically it has basically, you know, in EVNG, the router, this particular router which I have used, basically it has basically 4 interface modules, you know. So slot 0, you have basically the IP address is what? 0/0 to 0/3. Then it starts 1/0 to 1/3 like that, 8 interface. Whereas if you see here in the script, I basically, you know, I thought basically it will be all 0 to, you know, 0 to 7. So that's the reason it happened. So I need to do this correction. This has to be slot 1 interface 0 like this. Then what else? Let us see the topology again. 1/0 I need, 1/2 and 1/3 I need. 1/0, 1/2, and well, there is no 1/1, 1/2 and 1/3. Okay, need to do this correction. This has to be 1/3. This okay to the internet controllers cloud. Okay, this is there, and then 1/0, 1/2 I need. One more interface I need. 0/3, 0/0, 0/1, 0/3 goes to New York. 1/2 goes to LA. This correction needs to be done. 0/3 is New York. Very good. 0/2 goes to LA. No, this is wrong. There is no zeros. There is no 0/0, 0/1. This has to be 1/2, and it has to go to LA2. So LA2 it has to go. 10.111.1.251. That is the link to LA2. It shows. Okay. DC. This is DC1, DC2. Mm-hmm. So 1/2, DC1, DC2, New York, Dubai, and this is LA2. So in MPLS, basically, we are taking MPLS connection to where? Not to both the routers in LA, only to one router. That is, as per the topology, if you see, from MPLS, it will be basically terminating on LA2. So there is no 0/2. Okay, 0/0, 0/1, 0/3, no 0/2, then 1/0. There is no 1/1, there is 1/2, and then there is 1/3 basically. So now the script looks good. So service provider router MPLS is ready now. Okay, service provider router MPLS is ready. Now we have to configure our WAN edges to communicate via BGP in which VPN? VPN 0, because this is VPN 0 now. So this also has to be part of VPN 0. So everybody has to communicate with VPN 0. So now what are the thing? So what will require now? This is VPN 0. For VPN 0, do we already have a VPN template, feature template? Yes, VPN 0, we already have a VPN template. Second, did we create earlier VPN interface template for VPN 0? Yes. For the internet, we already did one interface template for the internet, for the VPN 0. That is also done. But now we require what? One more interface. Because the second interface is connecting to MPLS. So basically, VPN 1, VPN 0, basically this feature template we require, but that is already there. That is already existing. Now we require what? VPN 0. We require second interface feature template. This will be required. And now in the third case, now what is the routing? Now this time what is the routing? The routing is not static or default. This time the routing is what? Dynamic BGP. So do I require a routing, this thing VPN 0? I require what? Routing.
Sir, I have a doubt.
Routing feature template. Yes, tell me what is your doubt.
See, for VPN 0, for INET, we already has VPN 0, right?
Feature. Yes.
So again, if we create for MP.
No, I'm not creating. I said it is already there. I'm just you know, I'm remembering that. I'm just asking myself, is it there? Yes, already there.
Okay.
We have to, you have to always remember these steps.
Yeah, but my question is, everything will come under VPN 0, right? All the interfaces in the one site. So if we create again VPN 0 for MPLS, so will not there be any conflict?
No, you're not creating MPLS a separate VPN. No, you're adding new, this same VPN in 0 template. I'm going to add one more interface now.
Oh, okay, okay. Under the VPN 0 itself.
Because that's the reason I'm picking this. Na. I have to create this one and this only. I don't have to create again a new VPN 0.
We will create interface template.
Yes.
Got it, yeah.
Like that. Okay. But you know the concept
Second
is
interface template.
Concept is always you have to remember. Concept you have to always start with what? You require a feature template for the VPN, then you require a feature template for that in VPN interface, then you require a feature template for routing, and then again you have to ask yourself, what is the routing? If it's a static routing, then you don't require the feature template. But if it is dynamic, then you require a routing. This is how you have to remember, and you have to put it get it printed in your mind, like that. Concept is important. No? We have to understand and make the concept strong. Okay.
Yes.
Shall I proceed now?
Yeah.
Okay. So all said and done. Let's continue now. We go to where? Configuration templates menu. And we see we have some here. I go to the feature templates. So if you see here, we already have this feature VPN 0. So I'm not going to create this. This is already there, like that. And then if you see earlier, I already have one feature template for the interface also. Now I have to create one more for this. So we'll say add feature template. Select like as usual, select the model. And I select now, I go straight away to the VPN interface Ethernet type. I'm creating a new one. So I'll clearly say this is again basically VPN 0, and in VPN 0 basically now my interface is what fixed. So I'll say it is basically G. What is the interface? It will be like 0/0 and 0/1 will be always used like that. But again, I have you see basically we again have see there is an exception now. Everywhere I'm using basically for MPLS connection what? Gigabit 0/1. But if you see here for LAVH2, basically I'm going to have what? Gigabit 0. So just basically with respect to one interface, with respect to one WAN edge, if I make it device specific, then I have to answer 5 times. For DC also I have to specify, no, you have to use gigabit 0/1, DC to gigabit. Only for LAVH2 I will say no, the interface will be gigabit 0/2. So I can make it device specific also, but if I make it device specific, then it is going to ask me basically specify the interface multiple times. So I'm not going to do that. I'll say no, this is basically gigabit 0/2, because for LAVH2 I can create one separate template for that, so that it minimizes. Otherwise every time I have to keep on specifying. Okay, this is, if I make it device specific, just think, if you have basically 100 locations, 100 times you have to specify the interface. So it all depends like that. Okay, interface has to be always up. Interface name, since it is basically device specific, so I'll very clearly I'll say it will be always gigabit 0/1. So I make it global. So everywhere so that means this feature template I cannot use it. I cannot use it for what? LA2, because LA2 has a different interface. Okay, no problem. Then IP address, yes, IP address. Then we'll specify device specific, and in the device specific we'll say, okay, this is also basically VPN. This is basically VPN 0, but this is basically which interface? This is basically MPLS interface IP address. We are talking about MPLS interface IP address. So it looks good now. So it will make sense while entering the value. So VPN 0 MPLS interface IP address. Okay, but because this has to be device specific, because IP cannot be same on all the sites. Looks good. Okay. So VPN 0 second interface template we have created now, like that. Okay. Done. Now next will be what? I require a template for routing. So routing is what? BGP. So I need to add again a feature template BGP. I select the model. I go down, select the BGP template. This is basically BGP for which VPN? VPN 0 BGP. This is a VPN 0 BGP feature template. If remember, we already have a BGP template for service VPN. Now service VPN requirement might be different, so that's the reason better to have a separate template. If I want, I could have used this in that same template also, but then to make it look big, there can be multiple templates. So Control C. Like that. AS number. Okay. Now this AS number will be what? Fixed, because our AS number, this is AS number means what? Our own AS number. So basically it will be fixed basically. So I'll make it global. And what is our AS number? 200. So all the WAN edges there, because that is what if you remember, that is what we basically manipulated here. I corrected this one. AS number say 200. So XYZ, this organization XYZ, they have a BGP AS number 200. So AS number 200, yes. Then I go to Unicast address family. Like that, I check whether it is IPv4, it is IPv6, it is IPv4 only by default. Like that. And then we go to the neighbor. Third is I go to the neighbor. Like that. In neighbor, basically we have to specify the neighbor. So we have to add a neighbor. Again, this neighbor address cannot be global, so I'll make it device specific, and in device specific also I'll make it basically we are talking about BGP. There could be multiple service VPNs having different BGPs. So basically this I will again make it, this is basically VPN 0 BGP neighbor address. Okay, that means the MPLS, or actually I can even make it basically MPLS BGP neighbor. Like that. It's good. Remote AS. Now the neighbor, the service provider AS number cannot be, cannot be changing. Service provider can change also if it is basically, in different locations they have basically different.
The description did not change, sir. It is same.
Where?
Yeah, that only. It did not.
No, here I change VPN 0 device.
Okay.
Interface field value as description I did not do only. No?
Okay.
I can put this description. I can say basically this is VPN 0 MPLS WAN service using BGP. This is something description, not mandatory. No? Remote AS I made it. Yes, remote AS will be. Now remote AS cannot be, it can be different device specific if it is changing, if the service provider is telling no, our AS number is different in different locations. But normally we'll make it global. Service provider AS number, what is the service provider AS number? I check from the MPLS router is running which AS number? 10. So I say service provider AS number will be 10. Address family off, no, I have to make it address family on. And once I on, I have to select IPv4. And then you see, like in traditional BGP, how we have basically see how many maximum prefixes we want. You want to allow only maybe 100 prefixes to be accepted from a particular neighbor. So that policy is also possible. Then somebody was telling, can we have basically inbound and outbound policies, route policies? So you see, if I say global, and then if I say on, then it will ask me policy. See what is, we have to define some names and all, like that. That is all possible. So whatever traditionally we do, everything is possible. All optional, no? Because every time everybody does not configure every time all the policies. So address family I configured, yes. Neighbor address, I will specify what will be the neighbor address for my BGP neighbor. What will be its remote AS address family? Looks good. So now add the neighbor. So one neighbor got added. That's it. So now for this VPN 0, for the second WAN service, VPN 0 is the same. We can't have a separate VPN 0. VPN 0 is common for both the WAN service. So now what we do, we have to attach this new feature templates inside the device template, which is already using VPN 0. So we go to the device templates now. Let us do the first thing for data center location, because data center is over here. We go, we say edit VPN 0 and VPN 512. Basically they come under what? Transport and management VPN. See, two different categories of VPNs, transport and management together, and service is separate. So I go inside transport. Right now, if you see, VPN 0 only has one interface. So I will say, no, I want to add one more interface. And this time I select what? VPN 0 gigabit 0/1 feature template. See, earlier already there. That is now one more I'm adding. And now this VPN 0 will also have now what? Routing again supported is BGP OSPF. So we have selected BGP. So have I created a BGP template? Yes, for service VPN 200 separate was there. Today we created VPN 0 BGP template. So I add that BGP template, which just now we defined, and I say update. And in the meantime, what we do, we keep this MPLS router, because right now, if I go to the MPLS router and if I do show MPLS, show IP BGP summary, you see all the neighbors basically are either in active state or basically they are basically idle, like that. Because right now no neighbor is up. In fact, the neighbor don't even have the IP address also. So now it is telling us the two devices. So let us first provide the values for the DC1, data center 1. Okay, so I provide the data center 1. What is the new information? It says, okay, give me, it is telling give VPN 0 MPLS interface IP. So MPLS interface IP will be what now? So we need to check again with the MPLS router. Let us see, it is telling it will be 10 dot, this will be the IP address. So I copy from here. This will be the neighbor address. So this will be the IP address of DC data center 1. Paste /24.151. So 10.111. No, how it can be 10.111? Sorry, no. No, this one 10.122 should be 10.122. Now the problem is there. You see here, this, if I select 10.122.1.151, you see here on top, system IP is already 10, same IP. System IP cannot be same as the one of the interface IP. System IP has to be unique. No, two interface cannot share the same IP. So I right now what I can do, I will correct this also. I will say basically it is 10.1. 1 dot third octet will be the site IDs, like that. We'll make it. So 10.1.122.151, whereas the IP, because service provider has already decided this is the IP addresses of the on the links. So he has already configured on his site 10.122 IP for data center. Then the second for Dubai, maybe he's configured 10.144. New York, he already configured 10.133. So some service provider is not ready to change. So if service provider is not ready to change, we have to change our site. So I'm changing system. This is what you have to be careful, because for system IP also I use what? IP addresses from the same 10 subnet. So there could be a conflict. So better check and do. Then the address, neighbor address will be 10.122.1.251. Remember I said in iNet router IP addresses are ending in what? 250, and for MPLS I said it will be ending in what? 251. 250 and 251 for each service provider we have decided. So I say update, information complete. Green tick means what? We have provided the information. Now second device, same way second device. Again, this will be the IP. Again, see if you see here also 10.122. So this cannot be 10.22. It has to be 10.1.122.152 like that. And same thing here. It will be 152. Second sub third octet will cannot be 1 now, and this is 122. How I know? Let us compare confirm this from the MPLS router. Second neighbor, see the second neighbor IP is 10.122.2.152, or better from here itself copy and paste it. So looks 10.122.2.152/24, and then again, and I make it 251 because MPLS IP address will be ending in that subnet, ending in 251. So all the IP addresses, if you see, if I go to the MPLS router, show IP interface brief, it's ending in 251. Let's see now, these two routers, they form BGP neighborship or not. Let's see. BGP neighborships are all down right now currently. These two neighborship must come up. Once the configuration is pushed, they will get an IP address, and once they get an IP address, then BGP will be configured, and once the BGP is configured correctly, I should see neighborship. And there you see MPLS router, service provider MPLS router has established BGP peering with customer router. Like service provider is P, customer is C. So PEC routing protocol is MPLS. In MPLS it is BGP. So now the service provider router P router has established peering with the C routers of the customer edge. 10.122.1.51, 10.122.2.152. And then like that, as I said, this service provider for testing purpose, I can in the BGP configuration, what if you remember, I advertise some advertising one network by the network command. So I can check it now over here. Okay, still progress, still pushing, still no success. Why it is taking so long? Should not for finally came. Good. Okay. But anyway, before that only we had seen that it was already pushed. The thing was, the problem why it took so long, because there was a major change. You know, if you see system IPs, it is still showing this old system IPs, but now we have changed system IP. So there has been a major change in now. Basically, the system IPs have changed now. See, it has reflected now. I made it 10.1.122. So this changes it had to do, you know. So after doing this, it has to, you know, this information has to be propagated to everybody. It's not only sending the information, vManage has to send the information to the DC1 and DC2. After that, vManage also understand that now the system IP for these two basically WAN edges has changed. So the other controllers, everybody must get updated. And that is where this, because this WAN edge list is basically sent to everybody. So everybody now is aware that, okay, like that. Now if I go to the again network monitor, okay, and I go to vSmart, if we check now OMP peers, if I go to the real time, I say show me OMP peers. It should show here now the IP address. The IP address has changed now for DC1 and DC2. 10.1.122.151, 10.1.122.152, like that. For DC, it is looking good. I think for New York, maybe we have to, New York, we have to do this change because this third octet has to be the site ID. We'll check, we'll do that later. But now at least that's the reason it took time, like that. And now if I go to DC1 now, let us go to DC1, data center 1, and real time. I say now show me BGP peers. Now DC1 is running BGP, so I say show me BGP neighbors. So it will show me BGP neighbor as what? The MPLS router. Say one neighbor, it is telling 10.122.151.251. This is the neighbor. And is this neighbor, is he sending me some route? Is he sending me some prefix? That will be reflected in BGP routes. So if I type again BGP routes, so if you see 100, as I said, no, on the MPLS router for testing purpose, whether BGP is working nicely or not correctly. So this is the prefix the MPLS service provider exchanging with the customer. So BGP configuration is good. So now for whatever templates we defined, that worked good for data center. And if it worked good for the data center, let us implement that for the other WAN, other locations also. So again, we go to the device templates. Let us do it for New York and Dubai. New York and Dubai, they are again in the same device template. So again, we go here, I say edit. We go to the transport and management section. One interface is there. I say I want to add one more interface, one more WAN service. For that, I have a special interface. And then this is going to use BGP here also. So I say BGP, use BGP VPN 0. Template, update. It will automatically show that New York and Dubai needs to be updated. So let us update now Dubai, edit device template. It is asking me, okay, what will be the IP address? Again, we confirm this from where? From MPLS router. MPLS router 10.44.144.1. This will be the IP address. No, neighbor, sorry, here. 151, copy. Come here. Paste. /24. Confirm with is it conflicting with the system IP? So in case of Dubai, it is not conflicting. It is good. On Dubai, we correctly put 10.1.144. So some places purposely I have kept the conflict so that we can we can understand and we should correct it. And neighbor address will be again cannot be basically 1.151. It has to be 251. So 10.144.1.251 is the IP address of the MPLS P router. This is the C router, customer C router IP address. This is the MPLS router P router. I say update. Same way for New York. New York, I think we need to confirm. See here, it is 10.133. Control C. Control V, but here I have to check, correct it. I have to make it system IP change 10.1.133.151. 251. still better to confirm from the MPLS router. MPLS router is yes second. See, in case of MPLS, second octet only the site IDs are configured. So based on the service provider PE router, we have to update ourselves. Configure. You guys actually should not do directly. You guys should do what? Check the intent. It will show you the configuration. It will show you should always see what new configuration is getting added. You can see the intent. What intent basically means what will be the new configuration which will be pushed. And if I see here, it will show VPN 0 or BGP is getting added. This neighbor address is getting added. Remote S is getting added. Address family IPv4 unicast it is supporting. And the interface will get, see, second interface will get this IP address and it will be in a no shutdown state. Like that. Okay, see, one more thing was, anyway, we'll right now, let us do that first, because we will see basically we allow, if you remember on gigabit 0/0, we allowed basically what, all this thing basically, the SSH and all. So that also for this thing encapsulation has to be a IPsec, because tomorrow if the internet fails in the traffic, the traffic will go through the MPLS. Via MPLS also the traffic must go secured. And that's the reason. Right now, let us configure, we can come back and again edit. Let us at least see BGP is working or not, interface is getting IP address and BGP working with the service provider right now. This time it is telling failure. What is the failure? So one router.
The system IP is correct.
Here it has to change now. Okay, let us see. For Dubai it went. Let us see. It says error on line 80, invalid value for address. So I did something when I provided that gigabit 0/1 IP. I think I did not specify. See, when I copied this, I think I did not put /1/24 IP. /24 I did not copy. So no worries. What I can do now, we go back to again the device. No. Devices menu. I'll go to devices now. New York issue was there. I say change device value, so it will automatically bring me here. I will provide the values again one more time. While copying this, I copied this here, Control C, Control V, /C, I did not specify /24. Subnet mask I did not specify. So that is what it was asking me, the error. And this has to be 251. Yes, and over here I need to change. I need to make this basically 133 and second octet 1. 10.1.133.151. So value I provided incorrect, and that's the reason it was failure. Okay, no problem. Let us see on the MPLS router, and I think it has already see. Now this time it has come up. Previously, see, it was active state. Now the neighbor is coming up. Neighbor BGP neighborship is already up. Dubai was already up earlier. And there we see basically now 4 neighbors are up. 4 neighbors are up. They're not advertising anything to the MPLS router. Okay, anyway, it will come up. It will, because it has to update all the controls and all. That's the reason it takes time whenever system IP is changes. That's the reason, whenever system, say in case of OS main router IDs also, whenever we change the router IDs, we have to clear the processes and all, right? Like that. So same way here also, system IP is like a router ID. If it is changing, then it has to be reflected to everybody. So it will take time to converge. In the meantime, now, anyway, MPLS is done now. Now the question is, if you see now, by the time this is happening, let us take. This is our MPLS router. Okay, let's take 2 devices. Let's take, this is basically DC. Let's take DC1. Okay, let's take another this guy.
LA2 we did not configure, right?
Huh?
LA2.
Right now LA2 we are not configured. No problem. Now let us take New York. Let us take 2 examples. DC1. Here is eBGP, correct? Here is eBGP, right? Yes or no? I created a loopback here, 100.1.1.0. I advertise this into BGP. So this MPLS router gives this route to DC. It gives this route to this New York also. If you remember, on the DC router, I checked also BGP route. It was showing 100.1.1. It is receiving. Now the question is, I'm not interested in what MPLS router is advertising to me. What is the requirement is what? All the WAN edges must have reachability to each other, correct? All the WAN edges must, that means underlay has to be up like that. So at this moment now, okay, if I go to, let's say, do we have any, what is this VH? Who is this VH? Dubai. Dubai. So Dubai, basically from Dubai, let's say if I ping now, ping 10.144.1.251. So see, Dubai is able to ping the MPLS service provider PE router. But now the thing is what? Can Dubai access data center 1.151? Can Dubai router access data center? Why it is able to access? Let us see the BGP routes. Show BGP routes. So it is showing, it is learning. See, it is learning this loopback from, it is telling I'm learning this loopback from here. Then it has this VPN 200 routes. That's it. It is learning only one. It is only learning only one route prefix. But the question is, how now Dubai was able to ping data center?
Because yesterday we already sent to OMP BGP actually.
No. That OMP, that BGP is basically different. No, that is service VPN route. This is service VPN. See, that was yesterday. This is yesterday. 4420. That is VPN 200. I'm talking about. I say basically show me BGP routes for VPN 0. In VPN 0, I see only one route, 100.1.1.1. That is a loopback on that MPLS router which I advertised, like that. Other routes, I don't know basically. The question is, where is the diagram? how I'm able to access this? How Dubai was able to access DC? My question is this, like in this case, or basically, let me clean up this. How this Dubai router, it was able to access this IP address, gigabit 0/IP address here, because this segment Dubai router it will learn only if this MPLS service provider router. Okay. In the MPLS service provider router, we have, I think I have the configuration. See here now. This is the MPLS router service provider. No, it is not there. This is the BGP. Actually, this command there should have been a command redistribute connected. If redistribute connected command is not there, that's the reason it is not it's not advertising the links to all the WAN edges. All the WAN edges must have reachability. So how that is happening basically? How the Dubai WAN edge basically is going? Can trace route 10.122.1.151. Trace route. No, I have to specify VPN. Which VPN? So I have to specify VPN 0 10.122.1.151. It is telling, it is sending the packet. Oh, see, it is using internet. It is using internet connection. Why? Because my Dubai router in VPN 0, it is already having what? A default route, correct? It is already having this default route. Then I'm telling to go anywhere, go via iNet router, like that. So see how it is happening basically now. Try to understand this first. So when I want to reach the data center, if I'm doing this ping from here, I'm doing from Dubai, I'm doing ping 10.122. Just I'm just writing 2 octet. Please understand. 122 means DC1. When I do this 10.122, my Dubai router is checking what its routing table. Okay. But and when I don't specify any VPN, by default it will check what the VPN 0 routing table. In the VPN 0 routing table on Dubai, there is no specific route for this. There is no specific route. So what it will do, it will go for the gateway of last resort, that is its default route. Default route says that if you want to go to 10.22, send the packet to where? So he sends the packet to this guy. So now the packet lands on the iNet router. What iNet router is doing? Let us see. iNet router must be having I must have created a static route that hey iNet router, if you receive any packet for subnet 10, you have to forward the packet to this MPLS router. If you see iNet router and this MPLS router, basically they're interconnected. They're all part of the same subnet on this side. iNet router IP is 192.168.0.250/24, and MPLS also is having a link over there. And because of that, it has reached. So I think iNet router will have a route. I think I must have configured a static default, and there you see a static default I've already configured. I said, hey, iNet router, you want to go anywhere if you receive any packet for 10 network, forward the packet to MPLS router. Same way, MPLS router also has a route. I think static route. MPLS router also, if I do now, show run pipe section route. I say, hey, MPLS router, if by chance, if you receive any packet meant for 180.10/16, you forward the packets to the iNet router. You see? Oh no, iNet router is not having one. It is having an old route, 172. iNet router does not have that traffic, but it has a default route to this gateway. No, this route is now 170. There is no 172.16. This should be corrected. It must be. But anyway, if route is not there, it must be 180.10. thing is that so inet router, the packet came. Inet router, what it did, it forwarded the packet. It gave the packet to the MPLS router. MPLS router, this is a directly connected subnet, so it forwarded the packet back to DC. So echo request landed on data center. Echo request landed on data center router. Data center router, what it does, echo reply. Echo reply, the packet came with which IP? I did not specify any IP. I simply specified what? 10.122. See, I did know a ping, no? From the Dubai, I did a ping, just specified the destination. So I did not specify any, source IP. So it must have taken this IP, gigabit 0/0. And what data center this guy did? It forwarded the packet back to this guy like this. So packet went through internet connection, came like this, came here, and then it went like this. It did not use the MPLS connection only. Not at all. It did not use the MPLS connection. Now, if I go to the inet router and I remove this route, let's say we remove this route. And now the ping will fail. If I go to again now, if I go to the Dubai router, now this time the ping will fail. Ping 10.122.1.151. See, ping has failed now. Why? Because now the route is but it should not happen like this also, no? This is basically an IP in 10. So through internet also they should be reachable, and through MPLS also through the internet, because MPLS is like a backup we have created. If internet is available, that is fine. But if internet is not available, then the WAN edges must still have reachability to each other through the MPLS cloud. So see, now this is failing now. Dubai router is forwarding the packet to the inet router. Now inet router does not know the destination 10 because I just now removed that static route. So that packet is getting dropped at inet router. So we have to correct this thing now. Are you guys understanding what I'm trying to do? Why previously ping was working? Because the inet router, there was this default route was there, static route was there on that inet router. Like that. If I again put up the route, ping will work. You see, again install this static route, again ping is going to work. The ping already started working. Now ping is working. Okay, continuously working. I go back, remove the default route, remove the static route, ping stops. See, ping failed. So what I explained, the packet flow, that is correct. Dubai router is pushing, it's not using this interface at all. It is using this interface and forwarding the packet to inet router. Inet router is checking his routing table, it does not have that static route, so it drops the packet now. And that is what we want. First of all, my Dubai router should not forward this route to the inet router. It should not use the default route. It should use this connection. It should use this connection to go here. Should not use this connection first at all. So right now, since I'm removed that static route, it is failing now. So it is failing. So now we have to get. Now the question is how this Dubai or how this New York will learn about data center, or how the data center will learn about this. So these are the links basically. This is the links basically. So in BGP, what I can do on the MPLS service provider router, MPLS service provider router is responsible for providing this routing, right? Connection, providing reachability to all the locations. So what I need to do, I need to go to the MPLS service provider router. I need to go inside its BGP. So run pipe section BGP. Go inside BGP. I need to say redistribute connected. So once I say redistribute connected, the MPLS router will advertise all the links. Like that, it will advertise. Let's take example neighbor 10 dot Dubai 144.1.151. Now you see it is advertising all the links to the Dubai router. It is now advertising 7 prefixes. Earlier it was advertising only 1 prefix, that's loop back. Now it is advertising 111, 122.1, 122.2, DC2, New York, Dubai. Even that this link, this connection, because it is basically that internet connection, so that also gets this thing. So it is advertising all this thing basically to the, and now based on this, let me save this first. Again, I come back to now VH Cloud, and now you see reachability already established. The moment I said redistribute, why? Because now Dubai router is learning the route through BGP. So if I do now, I say show BGP routes for VPN in VPN 0. You see, previously it was showing only 1 loop back. Now you see it is telling, okay, I'm learning 10.111.1.0. Who is advertising me? This MPLS router is giving me. Then 10.122.1.0. So now the MPLS cloud underlay is up. At this moment, now only MPLS underlay is up, because here we are not doing default. In case of MPLS service, we are not doing any static or default routing. In case of INET, I had kept it only default route, but in case of basically MPLS, it is BGP. I wanted to introduce some complexity. That's the reason I kept it in BGP here. And then in BGP, normally the links will not get advertised, and so I had to do what? Redistribute connected. Once I did redistribute connected, then all these links got advertised to all the BGP neighbors, and now all the BGP neighbors have reachability to each other. And now at this moment, now the underlay is up, MPLS underlay is up. LA2 we are still not configured. So this is right now we are doing. We'll do that. As I said, now LA2 will come later as a backup for LA location. Right now. Right now we have to assume that in LA there is only 1 router, and that LA router has only 1 internet connection. That's it. So as of now, underlay is up now through this thing. Now the question is, tomorrow this internet fails. Suppose this internet router fails. Will all these WAN edges will they still be able to establish the connection to these controllers? They should have connection to the controllers also, right? Like that. If you remember what I did, redistribute connected I did. So this is also 192.1. So this link also got advertised. That means now the controllers, they have connection via even through the MPLS cloud also. The second WAN service also, they have the control connection. This is very important. Like that. All the controllers, they must have reachability. So through this BGP redistribute connected, they have this reachability. But what about the controllers? See, previously the controllers, we had given what? I had configured what? Static routes on these controllers in the very beginning, that you want to go to this, all these WAN edges, will have IP address belonging to this subnet. All the WAN edges, they have basically IP addresses belonging to this subnet. So we had created that static route pointing towards this inet router. But suppose this inet router is failed. Now they are going to take IP address from this range. So when the devices contact the controllers using this IP, then these controllers also should have reachability to this WAN edges, right? And that's the reason. Let us check on one of the controller. Let us go to vSmart only. Let's take vSmart. So run VPN 0. You see, we have only 180 route. This is for the real actual internet, and this is a static route for 180. So all the controllers we need to add what? A static route, because tomorrow the controllers are, right now the inet router is there. If the inet router fails, then all the WAN edges will lose connectivity to the controllers, because through the MPLS they know how to reach the controllers, but the controllers, they don't know the return path. So what we need to do, I need to configure. We have to configure on the controllers, because second WAN services come up. So we go inside, we specify IP route 10.0.0.0/8. Gateway will be 192.168.0.251 MPLS router. Same thing on all the controllers. In the very beginning, in the script, in the that notepad script also I could have added, but I just wanted to show you there could be routing failures whenever you are adding a new WAN service. So you have to take care of the new WAN service requirements. If I go to the vManage or vSmart configuration, see in the script, see it was there actually already there, but I did not copy paste this thing from this text file. It is already there. See 10. This route is already there. This has to be corrected. It has to be 180. Same thing vManage also. Then the next section, down manage inventory. Again, this also we have vManage also saved. vBond. vBond also. So all the three controllers, they must have static route for the inet IPs also, and they must also have the static route for the MPLS IPs also. Otherwise, they will not have reachability. If inet fails, the reachability will be gone. All the WAN edges will be out of the fabric. Okay, guys, clear what I'm doing? Because we have to think now. MPLS means if inet is not there, then MPLS will be the WAN service which the WAN edges have to use to communicate with each other also, and to communicate with the controllers also. So when internet connection is not available through MPLS, the controllers must have reachability to the WAN edges, and the WAN edges must have reachability to the controllers. How the WAN edges got reachability to the controllers? The MPLS service provider through BGP provided that information. That subnet was advertised by the MPLS router, like that. How the controllers will learn about the WAN edges? We have to do static routes on them. So in the beginning itself, you can do this, or when requirement, like now I did not do in the beginning because I wanted to explain you guys that why it is needed, why the static route is needed. Because if the static route is not there, if the internet fails, all the control connections will go down. Okay, we take a break now.
Yes, sir.
Okay, so we'll take a short break, come back again. It's like 12 o'clock, 12:15, we start again. Okay, let me quickly stop the recording.